The famous Greek mathematician Euclid, known as father of creative geometry, near about 300 BC, considered various plane sections of right circular cone and found many curves. Such curves are called conics or conic sections. Simply, we can say that when you cut a cone by a plane, we are getting a common section of both of them. That section is called what? Conic section. So, cut the cone by a plane, you are getting some section that is called what? Conic section, which is purely two-dimensional figure. Now, we will try to see the analytical way of looking into conic. That is, we look upon conic as a locus. You know that locus is a set of points, and those points satisfy some geometrical conditions. So here, the whole base of conic section is very fundamental, which is one fixed point and one fixed line, which is not passing through this point. So, one line and one point determine a plane. So, in this plane, I am going to develop the conic. Let us see conic as a locus. So, I am collecting those points P in the plane of fixed line and a fixed point. Let us name this as some D called directrix, and let us name this fixed point, say S, called focus. Now let me choose such a points P in the plane such that the ratio of the distance of the point P from the fixed point to the distance of P from the straight line. This distance is a perpendicular distance. So, I am joining S and P and I am dropping the perpendicular from P on this fixed line at say M. If SP upon PM, this ratio remains constant for all positions of the point P in the plane, then set of all such a points P when we see together is called conic or conic section. So, SP upon PM is constant, and this constant is denoted by a letter E called the eccentricity of the conic. So, SP upon PM is equal to constant. Constant is denoted by E. This E is called eccentricity of the conic. Now, with the help of this, as I am dealing with the two distances, I can make the three cases over here. Case 1, that the distance SP and the distance PM is same. When SP is equal to PM, automatically this E becomes 1. When this condition is satisfied, if I am collecting those points P in the plane of S and D, such that SP is equal to PM, then the locus form by P is called a parabola. In parabola, as a conic, E is the eccentricity, which is exactly equal to 1 because SP is equal to PM. If I consider now the distance SP smaller than distance PM, then this eccentricity will be less than 1 because the numerator is smaller than the denominator. So, here I am choosing second case, that SP is less than PM. This means E is less than 1. In such case, locus of the point P is called an ellipse. So, it is ellipse. Third condition, if I consider, what condition is left? SP equal to PM, SP less than PM. Now let us consider SP greater than PM. So if SP is greater than PM, that is SP upon PM is greater than 1, but SP upon PM is E, so E becomes greater than what? 1. In that case, I say that conic locus of P is called what? The hyperbola. It is called what? Hyperbola. So, one can classify this conic in 3 categories. 1, whenever this eccentricity is equal to 1, we call the conic parabola. When the eccentricity, this constant ratio, is less than 1, then the conic is called ellipse. And whenever this E eccentricity is greater than 1, the conic is called a hyperbola. Now, we will try to find the general equation of conic. Means, we will get some equation which is representing conic. Now, suppose this point, fixed point S is alpha comma beta. And this fixed line has the equation Lx plus My plus n equal to 0. Suppose the point P is xy, any point of the conic. So it will satisfy the condition SP is equal to E into PM. SP upon PM is E, just cross multiply, I get SP is equal to what? E into PM. Can I square this? Yes. So, if I square this, I get SP square is equal to E square into PM squared. S is known to be alpha, beta, P is known to be xy, so distance between S and P can be given by the distance formula x minus alpha bracket square plus y minus beta bracket square is equal to E square. Now from this point P, we have dropped the perpendicular on the line D, whose equation is Lx plus My plus n equal to 0. So by using perpendicular distance formula, we get this is equal to, what is the perpendicular distance formula? Lx plus My plus n divided by square root of coefficient of x is L, its square, coefficient of y is m, its square. So this is the distance PM, but we are squaring this, so this becomes PM square. Now observe that this can be declared the general equation of conic. But what kind of equation we are getting? If I expand this, I realize that here some x square term is there, then minus 2 alpha x, then some constant alpha square, then y square term is there, minus 2 beta y plus beta square. So x square term is there, y square is term there, x term is there, y term is there, and constant is also there. Similarly, if I expand this, I will get here x square, y square, constant square, then xy term also I get, then term in x I can get, term in y and constant. So, moment I am getting in this equation, term in x square, term in y square, term in xy, term in x, term in y and constant, this equation can be generalized or it can be written in general as a second degree equation in x and y, which I can give as ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Here x square I am getting with here L square x square into E square and this root of L square plus B square. After squaring, I am getting some coefficient of x square, I am calling it A. Some coefficient of xy I am getting, I am calling it 2h for convenient. I am getting some coefficient of y square, some coefficient of x, some coefficient of y and constant term. So all such things are denoted by these letters, these constants A, 2h, B, 2g, 2f and c. conveniently, and we can write the above equation in this form, which is called the general equation of the conic. We know from pair of lines that whenever ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of lines, then the discriminant of this equation is 0. What is the discriminant of this equation? Discriminant of this equation is given by delta equal to ABC plus 2FGH minus AF square minus BG square minus CH square. You have to remember this. This delta is given by what? ABC plus 2FGH minus AF square minus BG square and minus CH square. I'll give you an idea to remember this, right? So we can write these alphabets in alphabetical order. Suppose A initially, then B, then C. Then there is no E, there is no D, but there is FGH. So write here FGH. First you take the product of these three, right over here. Then you take the product of this and multiply it by 2. Then square this and multiply this and subtract here. Squares this, I am getting G square into B minus BG square, and square this H square into C that we are subtracting. So this way, this expression, which is called the discriminant of this equation, can easily be remembered. So ABC plus 2 times FGH. Now everything is minus. Minus AF square minus BG square minus CH square. So this is the discriminant of this equation. Now we know that when this delta becomes 0, then this equation represents a pair of lines. But when delta is not equal to 0, then this equation will not represent a pair of line. It may represent something else. Now what's something else? We know that number 1, suppose delta is not equal to 0. Under this condition, I am making certain cases. We have seen in circle that general second degree equation x and y represents a circle if coefficient of x square and coefficient of y square are what? Same, and the product term x into y is absent. Now if I find the factor h square minus ab, and if this comes out to be 0, then this equation will represent a parabola. So h square minus ab equal to 0 is the condition of parabola. Second thing, if this h square minus ab is less than 0, then this equation will represent what? Ellipse. And number 3, if h square minus ab is greater than 0, then this equation will represent hyperbola. So, whenever delta is not equal to 0 and we deal with h square minus ab, then it can be classified. This equation will represent parabola if delta is not equal to 0 and h square minus ab is equal to 0. Equation this will represent ellipse if delta is not equal to 0 and h square minus ab is what? Less than 0. And this equation will represent hyperbola if delta is not equal to 0 and h square minus ab is greater than 0. This way, we have derived the general equation of conic. Only one thing you remember, that this SP is equal to E into PM. This property is called focus directrix property, because SP is related with the focus, PM is drop perpendicular from P on the directrix. So everything is concerned with focus and directrix containing this E. So this is called focus directrix property. If it is satisfied, then what we are getting? The equation of conic. And you know that when E is equal to 1, it is a parabola. E less than 1, it is ellipse. And when E greater than 1, it is hyperbola. So this way, the conic can be classified into 3 classes: parabola, ellipse, and hyperbola.